webinar to do that. Okay, with that, we'll go ahead and kick off today's webinar, which is monitoring at the speed of DevOps. Why continuous deployment and continuous monitoring make a winning pair. Our speakers today are Kevin Crawley, who is developer evangelist at Instana, and he is going to be joined by Hugh Bryan, who's senior solutions architect at Instana. Welcome, gentlemen. Thanks for joining me today.
Thank you, Charlene. Just quick introduction about myself before we get started. My name is Kevin Crawley. I am a developer evangelist for Instana. I've worked with Instana since around April of this year. Before that, I worked for a company called Franklin American Mortgage Company, and prior to that, worked for a small startup called Built Technologies, where I was a DevOps practitioner, worked on automation, and really bringing the tenets and the advantages of DevOps methodologies to those organizations. So I've been using the Docker and maintaining distributed applications in production since around 2014. And I help organize events in my local area and speak on topics such as DevOps, automation, culture, and observability. And what we'll be talking about today in this presentation is how companies are tracking the performance of their software delivery organizations. What are some of the KPIs that they're looking at, and the benefits that they've observed from leveraging those DevOps practices, the challenges which have presented themselves to those who have begun rapidly adopting microservices and cloud-native architecture, and how Instana can deliver solutions by automatically detecting, instrumenting, and collecting the metrics, traces, and performance data for well over 150 different technologies. Now, after we get talking about the solution and Instana, Hugh will take over and he will deliver a demo, at which point, after the demo, we'll start taking some questions and answers from the attendees. So I wanted to start off today with talking about the State of DevOps report, which is actually a report that Puppet Labs has been publishing for a number of years now, at least 3 or 4. This report tracks the performance of modern software delivery organizations. They've identified 4 key metrics which can be used to determine the maturity of a given company's software development lifecycle. And what we're going to do is we're going to focus on some of those metrics here in a moment, but I do want to talk about some of the other benefits that these high-performing organizations have seen from implementing automation in several key areas. So it's worth pointing out that this report does cover in depth many more observations than we're going to talk about here, and the data to back it up. We just simply don't have time to go over a 100-page report that this white paper delivers. So some of the things that, some of the key takeaways from this report have been that the SDO, or software delivery and operational performance, has been critical in unlocking competitive advantages such as time to market, customer satisfaction, and agility, or the ability to pivot. It's also told us that outsourcing functions or teams has quite often a performance detriment to your software delivery lifecycle, and that logging, monitoring, and observability are crucial for the high performers that they talk about in this report. So before we talk about what some of the advantages of bringing DevOps into your organization will have, I want to first talk a little bit about the metrics or the KPIs that these organizations have begun tracking and looking at to get a better understanding of how their organizations are performing. So the first one is throughput, and this is directly measuring the velocity of your application delivery organization. The 2 metrics that they really focus on here is deployment frequency, or how often changes are deployed into production. And the other one is the lead time for changes. And what this really measures is how long does it take an idea to get from the project management or the product management team into an actual change in production. And the next segment that we're going to look at is stability. And what this is doing is measuring the resiliency of your application's delivery organization. So instead of the velocity or the speed at which changes are being made, this is looking more towards the reliability and the stability of those changes. So the two metrics that they look at here are time to restore service, or if we do push out a change in which causes a negative impact on services or the end user, how long does it take to restore that SLO or the SLA that was in place in which was not observed or was violated? And the other side of that is the change fail rate. How often is this happening? How often are we pushing changes that do break something? And what this report has given us is a really good understanding of organizations and what the measurement of these KPIs have been in relation to their performance, to their ability to deliver changes and to build software and get it out the door. So what it's told us, and there's some other categories here in which aren't nearly as highly differentiated. So you have medium performers and you have like the elite performers, which are way above high performers. But the reason I chose these two is because the differences between the two are great enough to be quite substantial, but at the same time, they are practical enough to where any organization out there that may fall into the low or medium category could easily see the benefits of the high performers within a year or two of really hard work of identifying areas where automation needs to happen and making those changes that are required to bring that automation up to standard for the organization. So the two ones that I want to point out is the rate at which deployments are made. So for the high performers, deployments could be made anywhere between 1 hour and less than a day. So that means within any given day, there is at least one deployment, if not more. And then the other one is the change failure rate. So we know that no matter what organizations do to automate the process of delivering software, at some point, bad code is going to be shipped. It's just a matter of when. And so one thing we've noticed between the high performers and low performers is that with low performers, even though they're shipping less software and less frequently, the rate at which those changes fail are higher than the ones that ship multiple times per day, to at least once a day. And the reason why that is, and the report goes into greater depth about this, is that typically high performers have more confidence, more testing, and more automation around the process of making sure that software that goes out the door is not going to break anything. The other side of that is that those organizations tend to push out smaller changes. So the impact or the potential for a problem to happen is much less so for the low performers, because of the changes that the low performers are pushing out are typically much larger. So, we look at what are some of the things that, what are some of the problems that can be caused in continuous integration and continuous deployment when you start talking about deploying microservices and smaller applications. And one of the things that we've generally observed, at least with our customers, which we've worked with over 200 companies and helped them bring monitoring into their organization and observability, is that in order to successfully have a true continuous integration pipeline where you are continuously deploying changes, you have to have solid monitoring around those systems so that you can understand that when you do push a change that does break something, you have immediate feedback. So one of the things that we've heard is, well, multiple things that we've heard from companies who are pushing microservices and containerized application is that within a matter of days, performance issues can become an issue as changes are rapidly being introduced. Introducing new endpoints and new services into the system comes at a pretty high cost, because whenever you introduce a new system or a new application, monitoring has to typically be built around that. Logging filters, alerts, all these things have to be done by hand typically, to make sure that when you do an application, it doesn't just fall down and break everything around it. And the other impact is root cause analysis has become more problematic as the complexity of these systems begin to expand. So using traditional monitoring tools or building your own monitoring, it has turned out to be quite a bit of work, and it's also very time consuming. Up until now, every monitoring tool has required some or all of these manual steps. Some of them are getting better at automating some of this stuff, but most of it still holds true. And without good monitoring, the SRE or the DevOps team really has no visibility into the operation and how the application is performing in production. And in this world where we talk about continuous integration and continuous deployment, manual steps, really, they just prevent the velocity and the speed that your organization needs to get software out the door. And thereby, it really does prevent you from delivering true observability and visibility into your applications. So some of the questions that you can ask yourself and determining, if our monitoring solution is up to the task, is how many of your services are actually monitored? Like, what are you collecting from that? Do you have every one of your services in production right now? Do you have an understanding of how many requests per second they are answering, how often they are throwing errors or exceptions, and what their average latency is? I mean, there's a lot of questions that we can answer, that we can ask here, that will give you an idea of how much value Instana can bring to your operation team. Some other questions that you can ask is, how much effort are the engineers spending to build this visibility? And if you're using an APM tool, what are you using, and does it help you automate some of these steps? So I want to summarize the situation we just talked about. If you don't have automation in your monitoring, you don't have very good visibility, and therefore you don't have very much velocity to get new services and new changes confidently out the door. What this ends up resulting in is unhappy customers and lost revenue. So without having an automatic monitoring solution, you're just left with limited visibility and turtle pace speed. So if we look at the CI/CD approach to software delivery, there's a never-ending loop to get the new business service into production as quickly as possible. And most organizations are using some, or if not all, of these tools to help them automate this loop, this never-ending life cycle. And really, up to this point, there hasn't been a real solid solution to help the automation or the configuration of the monitoring system to be a little more hands-off, a little less, requires less human intervention and human interaction to be effective. At the end of the day, any manual process within this life cycle slows down your organization. So what are some of the requirements for automated monitoring? I mean, we talk about what are some of the benefits, but we have to look at what are the requirements. And we believe that discovering and instrumenting your application services should be 100% hands-off, fully automatic. You don't have to install a library, a plugin, or change a configuration in order to collect the performance data for all of your application services. And now we also feel the same way about alerting. Our solution has a built-in knowledge base, and we apply machine learning heuristics to determine baselines. And what this ends up doing is it allows our system to learn what an acceptable amount of error rate in your system is. For whatever reason, if we notice an increase in latency or an increase in errors for systems that normally did not have this baseline level of performance, we will alert you about it. And you don't have to configure that. We just figure that out on our own because we do collect data in a high granular fashion. Every 1 second, we collect a metric and we collect a trace. So with our solution, all you'll need to do is install a single agent per virtual host, and Instana will continuously discover every technology. It'll automatically collect the metrics and the traces for every application request, and it will automatically map all of the dependencies so that when an issue does occur, that we can correlate that issue back to a root cause or a service in which initiated that issue. So at the end of the day, what we determined is that dynamic applications need automatic monitoring. And what that ultimately translates to is that we need the ability to automatically detect technology as it's deployed and or scaled. We'll need to automatically capture time series metrics and automatically capture distributed traces between your services. And then we also need to automatically analyze all that data and give you real actionable insights for that data. And ultimately, what our goal is to accelerate the delivery of your business applications. We don't want to slow you down. We want to let the Instana robot do all the work. So before I hand this over to Hugh for the demo, I do want to point out, what are some real life scenarios that we've seen solved with Instana. And I have one that happened a few days ago. But before I go into that, I want to talk a little bit about how observability is the new requirement. And what Cindy Sridharan has said is that observability aims to provide highly granular insights into the behavior of systems along with rich context, which is perfect for debugging purposes. So what does that look like? For this service, what we have, this is a screenshot of a database table that is seeing a logarithmic rise in latency. And Instana recognized this and sent us an alert about this issue, saying that, if this trend continues to rise, you're going to have a service in which is producing significantly more latency than it was, 12 hours ago. And what this actually was is, as a new sale was being made on a particular entity or an item in the database, that transaction was being recorded in a relationship table or a join table. And as each new purchase was being made on this, it was adding another record that had to be loaded anytime that record was, any kind of transaction happened on that record. So what we were able to do is, number one, we were given this issue by Instana to say, hey, you should come and check this out. And then we immediately recognized what the issue was. And as you can see, when we deployed the fix, we were able to immediately get feedback that our fix was in fact effective. We went from averaging around 1 to 2 seconds on the response time back down to sub 50 milliseconds. So again, this is just an example that automatic tracing and instrumentation gave us for this application. And I think it's worth noting that we literally had to do nothing to get this information out of Instana outside of installing the agent. Our agent discovered the application, the database, all the transactions happening between it, and then automatically started creating these dashboards to give us this information and to start alerting us about those problems. So I'm going to hand this over to Hugh for a demo, and then after the demo, we'll be happy to answer any of your questions.
Thanks, Kevin. While Kevin's doing that, my name is Hugh Bryan. I'm a senior solutions engineer at Instana, and I'll be presenting right now. So one of the things I always like to start with is the infrastructure and work up to the software, but we can do both and. So when you install Instana, we usually start, you start with a blank screen, but then after you install the agent, we get visibility. And so what we are showing you here is the deployment of the agent and its results on the infrastructure side. So as I click on and zoom into some components here, I'm actually seeing a representation of what is essentially my data center in real time. And what I'm going to do is I'm going to tee off on the things that Kevin mentioned. So one of the things that's going on here is this user interface here that you see is being updated in real time. And just to kind of make that point, what I always like to do is open up a dashboard and go to kind of real time mode just to show you that we weren't lying, right? So we go to live mode here and we've got data streaming in real time. And this will be true for any changes that have occurred that the agent has detected. We're also going to capture the performance metrics in real time. And we're going to be monitoring everything in real time. So it's changes, any problems that occur, and of course, performance metrics. Now, one of the things we have an agent that has sensors. And so when I click on here, you can actually zoom in and see I've got an agent with I've got a host here with lots of different items, right? I've got JVMs, Node.js, databases, RabbitMQ. Like Kevin mentioned, we have a lot of sensors and they're always monitoring. Additionally, for folks who are running in orchestrated environments, we fully support, looking at an infrastructure with a host view, but also a container view. So we can also give you visibility based on containers, right? And we can break those down by container name. We can also, group and sort them by different tags, if you will. And again, all of these things are done in an automated fashion. Now, just to kind of set the level, this is all of the infrastructure here that we're monitoring in real time. But there's also the software that's running on top. And we have two major views for the software running on top. And that is the application perspective, which is made up of, an application is made up of one or many services. And then we have services, which are essentially our first-class citizens. And then within those services, you have endpoints. But one of the things that we do after we deploy the software and we build out that infrastructure view, we're going to build out a dependency map view, right? So we're going to show service dependency kind of at the logical level, right? Service A calls service B, calls service C. And the service we're going to focus on here is our shop service. Now you'll notice as I move my mouse around, we're only going to see, we've got an aggregation of services here, but it's funny how each service knows who it's connected to, who's its neighbor. And we can do this both on the software service side, but also on the infrastructure side. And what that means is that when I click on a particular component, let's take our shop service down below, and I open it up, what you're going to see is a dependency map here, or a tree. So we're going to have a Spring Boot app running in, guess what, a JVM. And you'll notice as we walk down, each sensor has its own name. We type it. We're going to monitor its health, right? We're going to monitor its configuration information, and we're going to capture performance. And this is done for every sensor that's, again, automatically deployed by the agent. So the agent went through, it found, let's say, a Docker container. It looked inside the Docker container. It saw a process. It recognized that the process was a JVM. And when we looked at the JVM, we go, is it a Tomcat? Is it a Spring Boot? Is it a Drop Wizard? And we do all that automatically. And so you'll notice at every level as we walk down, we go to the process level. We have, again, we're looking at the type, what's the name, right? A lot of this is metadata. And so being able to dynamically or be able to monitor metadata that's changing all the time is a key part of this whole story. Not only are you seeing changes that are occurring and streaming in, we are also able to see performance data stream in, and we're monitoring that data as it flows through. And again, we're doing this at every level. And we're not limited to a Spring Boot app on a JVM. It could be a Node.js application running on a node process, not in a container, for example. Or it could be a Python app or a PHP app or a Go app. You get my meaning. And on top of this too, we're going to be able to see and link to the service that's running on top of this. Now, one of the things we didn't mention, but I always like to bring up is that why is Instana necessarily different? Well, primarily because we're not just metrics on graphs on dashboards, right? I've been working in the APM business for a long time, and that was kind of where we started. We said, let's get a metric and put it on a graph, and it'll tell us something. And so we said, no, let's start over. Let's model your environment. Let's represent it to the user, and then capture what's important, right? And constantly monitor that state. Now, the other way we have to do that is by monitoring particular issues, incidents, and changes. So when we go to this view of our screen, and we'll go out for a couple minutes here, we're going to see a lot of components here being monitored. And what we have at the bottom is we have changes. So anytime something is changed, again, this goes to what Kevin was talking about, where, hey, what is the consequence of a change within your system? And then all these sensor monitors generate something we call an issue. And then services, when a service has a problem, we generate something called an incident. And what's nice about this is that it gives us the ability to have both a time context and what we call a connected in the graph context or connected context. And so here, for example, we can zoom in on this particular incident. And what's nice about it is we have a time value, and I can zoom in on that just by zooming in on the timeline. But you'll see, who am I connected to? Well, here are the dependent services, and then we have the other issues that occurred based on who I'm connected to, right? So services are connected to each other, and services run on infrastructure that have a dependency map underneath them also. All right, moving further, we also have the ability to filter. So I have a couple of filters just baked in here, and I can say, hey, show me all of the NoSQL databases, for example, in the system. And we can see those here: Elasticsearch nodes, Mongo databases, Cassandra, etc. And again, if it's got a type on it, we can filter it. We could say just the Elasticsearch nodes, or show me all of the entities related to my shop service. Right? So that's a very powerful proposition. Now, there's also the ability for me to open up the shop service, and let's look at it. So again, as Kevin pointed out, and I won't go into a lot of detail here on this, but because he kind of already covered it, but applications and services all have curated dashboards, right? We have the ability to look at the SRE key performance indicators, throughput, error rate, and response time. We're also able to set our time range at our discretion and look at it however we like. We also are going to see endpoints and have the ability to drill into those endpoints and actually see individual calls that are related to this service. But one of the things I always like to point out is that, sometimes our services, right, they have lots of dependencies. And what I want to show you here is a couple of the dependencies that we have. And so we can see that we have a service that calls a RabbitMQ message queue. We have a service that calls a database, for example. And we have some other endpoints outside of our control that we're calling. So I like to point those things out. We're going to have, as we walk across our dashboard, we're going to have a couple of sub dashboards that, again, are built for us. For example, performance, where we're looking at a latency versus throughput heat map, an HTTP breakdown. We have error messages and log messages. And of course, what is the infrastructure component under which this is running? Now, just a quick note here. We have two kind of message dashboards we've created here. So one of them is for any error message that's thrown or written to the log during this particular service request. And then log messages are those messages that come out of the runtime environment here. Now let's actually look at the traces, and we'll wrap this up in just a little bit. But I wanted to actually be able to drill in and look at the traces that we have at our disposal. And so we capture a trace on every call. So the first one we'll look at is looking at our trace. We're going to see multiple calls here, and a trace is made up of one or many calls or or downstream service calls. And you'll notice that what we do at every level is we're going to time it. How long did it take? We're going to tag it with what its infrastructure, and we're going to type it. Is it an HTTP call? Is it a message call? Is it a database, etc.? And so we're capturing those in pretty good detail at every level. So we have the entry point for the service, the next call down. We have a product search service here. We have a call out to Stack Overflow. And so we have all of these things, and you'll notice we're capturing the metadata, number one. But number two is, don't forget, that infrastructure connector is at every trace. So where that call executes, think about it this way, we're kind of planting a flag and that says, hey, this request ran through this stack at this particular time, and it took this long. So you always are going to have the dependency tree, the infrastructure linked in addition to the metadata for the call and the stack trace. Now, last but not least, one of the things I always like to make sure I mention is this notion of, actually we have two more things, applications. So an application is one or many services. And this is really nice because you can have multiple teams in your shop. One team might just want to be able to see, hey, I only want to see all the Mongo stuff. You have another team that only wants to see a specific service. And so we can do both of those things. We may only want to see the Spring Boot services, for example. So here's an example of where I have an application that's made up of 7 services that are all related to my shop service. At the same time, too, we could say, hey, just let's create an application that has all Java components. And the nice thing is that we're going to show you the dependency graph regardless. You could take 2 completely related or unrelated services. You can put them in the same application, and the software will figure out whether or not they're dependent. All right, last little thing, just because folks always want to know, is that we can always go through on any of the incidents or alerts that we capture. We can, of course, do alerting and connect out to just other systems. So one of the things we have the ability to do is we can set up an alert on a specific filter. So we could say only alert on JVMs of this type in this zone, or only AWS thing items, etc. And then you can elect where to send them. So that's kind of a new way of thinking about monitoring with respect to we have typed everything that we've discovered, and so you can use a very simple filter to then go through and send a notification. Once you've figured out what you want to send, we can then decide to send it to the following integrations or backends. So that's my presentation for now. I'm going to hand it back to Kevin, and he'll be able to continue the presentation here. Let's see. Okay, there you go. All right.
Okay, so I think we are ready to start the Q&A portion. I did answer a couple questions already. If anybody has any follow-ups to those, feel free to ask, and I can, myself or Hugh would be happy to fill in any additional details.
All right, we have gotten some great questions in so far, so we will go ahead and get started with those now. But there's still time. If you have a question for either Kevin or Hugh, please go ahead and use your GoToWebinar control panel and submit your question. Our first question, if Instana automatically collects performance data, how do I turn that data into action items?
So the most important part of the so the way to answer that is we already do it in two ways. Number one is the performance data that we capture. We are always monitoring it. So we have rule sets. All the sensors that I showed during the presentation have health rules attached to them, and those health rules are constantly monitoring. So that's number one. So by virtue of the fact that you install the software, we are going to be monitoring all of the infrastructure under the hood using those sensors. And then the second thing is all of these services and that we discover, they are also monitored using some machine learning there to give you monitoring at with respect to response time, throughput, and error rate. And then finally, if you so choose, you can always override any of the defaults that we have in our solution.
Okay.
I hope that answered that question.
Awesome. Okay, next question. How long does it take to automate the monitoring function and start seeing data?
That's a great question. It's literally immediately, or not literally, it's within minutes. For example, and this is what's really fun. For example, if you want to try out our software, I do this all the time. I actually have an agent running on my Mac right now, and it makes the demo a little kind of not as attractive, but I actually show the customers the actual agent running on my Mac, and I can show what sensors are deployed and are monitoring. You can actually do this yourself. If you want to try out the software, you can download it and try it out. And I'll be happy to help you out with anything you need, or our team will get in touch with you, and one of our solutions engineers will definitely be able to walk you through it. But you run the agent, you start it up, and it will just start scanning your process table and start capturing data and instrumenting your apps. Same thing if you're running it in Docker.
Okay, well, that's actually a great segue to the next question, which is, do containers affect the ability to automate the application monitoring function?
Oh, that's the beauty of our software. Our chief engineer, Fabian Lang, and the team he works with. And when I first, just to give you a little context, when I first got here 2 years ago, I kind of didn't believe it. We had just implemented our Docker monitoring and what I internally call look inside and monitor. They had just implemented. So when I deployed, I had Docker running on my on my machine, and I deployed the agent into the Docker context, and what do you know? It found all 6 containers, and the containers were running different technologies, but for Java specifically and PHP, it automatically found and monitored them. We've now added that ability for Python. Node is next on the list, but the nice thing is it's real easy to do this, and we're real excited about with what we've done. One little follow on to that is for all you folks who are going to do orchestration, the beauty of this is when we built it for Docker, because it was so Docker friendly, it enabled us to run almost immediately in Swarm and OpenShift and Kubernetes.
All right, great. Still time for questions, guys. We've gotten a lot in, but we welcome yours. So go ahead and use your GoToWebinar control panel and submit your questions. The next question is, how quickly should an automatic monitoring tool, oh, I just lost it there, sorry. How quickly should an automatic monitoring tool be able to locate a problem?
Ooh, that's really good. Wow. Well, as fast as it can, I suppose. That's a terrible answer. I apologize for that. But
It's like, why do you rob banks? Because
right.
that's where the money is. Yeah.
So, and I also hate the answer, it depends, because
Yeah.
that's the all answer that says nothing. I guess seconds is best, but the trick then is to say, well, okay, if I discover something in seconds, how do I know that it's relevant? Of course. So that's the first thing. So number one is, I'll just rewind that question just a bit and say, well, how fast? Well, what data are you capturing? So what's your data resolution? If your event and data resolution is at 1 minute, well, the fastest you'll be able to discover something would be a minute. So I would submit to you that, of course, it's going to depend, but if you have 1 second data resolution and you have 3 to 5 second event resolution, you have the highest probability to capture something fastest, which is, since, again, it's going to depend on what the source of the problem is, but as fast as possible, I guess, is the best answer.
Okay. All right. Great. Let's see. Our next question. Oh, this is a good one. What platforms, languages, and frameworks can Instana support?
So that's all published on our website. Number one, you can go to www.instana.com. Also, docs.instana.io also describes this, and that can be very helpful. Like we said, we have over 100 sensors that monitor over 150 different things. But for languages, we support Java, .NET, and we recently came out with .NET Core. We do PHP, Python, Go, Ruby, and Node.js.
All right. Great. Okay, then next question. What kind of resources do sorry, I just lost it again. What kind of resources do the agents and sensors take?
Yeah, it's a great question. So here's where I think we have an advantage over the other vendors that are out there, especially on a lot of the, with respect to Java and .NET, but even all the others. We have a single agent and we have, multiple sensors, where the other solutions out there, other tools, have lots of different agents. And so you have to configure and install an agent for each one, number one. Number two, again, in the realm of Java, most of those other tools out there, they have a Java runtime and they have a Java agent deployed into each Java runtime, which has its own connection and own delivery mechanism, etc. We don't have that. Our sensors just deliver data back to the agent. But I suspect that we're probably the lowest overhead that I've seen, and I've been doing APM for, like I said, for over 16 years, and I've worked at many of the other vendors that are out there. So
Okay.
that's one quick answer. It's always low. And again, I'll caveat it with this at the end. We are designed to run in production. So every design decision that we make, and it is so that we don't affect your production monitoring.
Okay. All right, great. The next question is, let's see. I just had it here. Sorry about this. So what about the off-prem services, whether it's cloud, et cetera? Can you see these or monitor them?
So, when you mean, so AWS services, for example, and we call it cloud native services. Yes, we have the ability to have our agent collect data, and you can look on our website to see the AWS service monitoring. We do over a dozen, I think now. DynamoDB, S3. We're doing that for AWS. We are also currently working on making that available for Azure. So all those Azure hosted services we can monitor.
Okay. All right, great. Guys, there is plenty of time for your questions. If you have one, go ahead and send it on in using the GoToWebinar control panel. The next question, what is used as input to, sorry, my thing keeps moving on me. What is used as input to initialize Instana and allow it to consume information about the application/services/infrastructure?
Gotcha. So the way it works is the agent is deployed, and let's take a simple case like a Python app. We then discover a Python process. So we see the Python process, and we start monitoring that. Within that Python process, we scan that process, we look at it, and we say, hey, is it running a software component that we can monitor? If we can, then we'll automatically add our instrumentation. And again, we do that for Java and .NET and .NET Core, also for Node. It's basically a discovery process that at each level, we start again with a host sensor, captures everything we can about the host. Then we walk to a process. There could be a container involved, optional container, then a process, then let's say a specific type of process, Python, Java, etc. And each level, the sensor kicks off and will capture those elements. It captures the change, the configuration data, the health data, and the performance data, and the type. What type is this? And we're going to capture that data and pass that off to the agent. And again, walk up. What kind of Java runtime is this? Oh, it's a Spring Boot versus a Drop Wizard versus a Tomcat runtime, or a Jetty runtime, or a JBoss runtime.
Okay.
So that discovery is always going on.
Okay. So there's a second part to that question, which is how long does configuration typically take to obtain the kind of data you demoed?
Very quickly. So the answer is I maybe I'll take that on for another demo, and I'll actually do the discovery for you. I was actually pondering it, but there's a lot of that kind of geeks out pretty hard, and I'm looking forward with that. But once you start the agent up, it will scan the process table. It will identify instantly. It will immediately start scanning. And again, we'll use Java as the example, or no, let's use Mongo or Postgres or MySQL. It'll scan those, find those. It'll download the sensors and deploy them, and it's within minutes. The other thing that's really amazing to watch is, let's say you have a 10-node Kubernetes cluster, and I always like doing this. You literally within a couple minutes go from a blank screen to a screen filled with 10 hosts, and then all of the containers therein, and it's very powerful. It's literally in minutes. There are a couple of entities that require a little bit of configuration. For example, database monitoring will require a user ID and password for the sensor to collect the appropriate configuration data. But for the most part, I would submit to you it's about 95% completely automated. And again, it's going to depend on what technologies you're using.
Okay, great. Next question. Do you capture and analyze metrics at the end user level, browser or mobile, in addition to the network sensors?
We do. We have the ability to deploy a JavaScript agent into your browser based applications, your single page apps, and capture that end user experience, and of course all the async HTTP calls that go out of there, and then we can also correlate them with the backend traces I showed during the demo.
All right, great. Next question, what type of bandwidth does the agent require for minimal real-time monitoring?
Oh, it's very limited. It's not a lot. Let me pause it to you. Let me answer it this way. In the 2 years that I've been here, I've never had a customer complain about bandwidth utilization. Again, that's anecdotal, but even within in a broader context of because we're a small company, I know everyone here and I know everyone who touches customers. That has not been an issue yet in the 2 years I've been here.
All right. Next question, how does Instana map between application, service, and endpoint?
Oh, that's a good question. Oh, okay. So the internals of how that's all done, I should be stronger on that. Let me just ponder that. So typically endpoints are going to be, we'll take HTTP and REST-based type services are the best example, where you have a service has multiple endpoints. Now, here's the thing about services, and again, this makes us very different than other solutions that are out there. We can make a service definition include one or many runtimes, number one, right? So the first thing to remember is a service can be defined as this service is these 10 Java virtual machines running this Spring Boot app. So that's number one. But number two is you could include something else in that service definition. You could put an Elasticsearch entities in there also. So the service is a logical entity that has components within it. Now, the endpoints that we define from those would be for HTTP are URL segments. And the default setting for our endpoint discovery is the first segment of the URL. However, that being said, we have recently come out with a new URL segment endpoint mapper, which will take specific endpoints that have unique IDs in them and abstract those out and put so let's say you had REST API/person and then an ID. It will create an endpoint called API person/ and then put a placeholder for ID. So it would do like curly brace ID curly brace, and so it will make that generic. So that's how we do that. And it's pretty good. It's brand new, and it's. I was talking to our product manager yesterday, and it seems to be working very well.
Nice. Okay. All right. Well, doing a quick time check, we're about 5 minutes to the top of the hour, so I think we have time for one or two more questions. Here's the next one. If organizations are in the beginning stages of CI/CD, how do they integrate traditional software dev and deployment with CI/CD operationally, especially for mission-critical applications? For example, moving from a 3-tier software design to a microservices framework.
I can take this one. So I answered a little bit around this because this is something that I've done with a couple organizations prior to working for Instana, and realistically, this was more of a cultural change and more of a trying to convince the major stakeholders within my organization that this effort was worthy of doing. And realistically, things like the state of DevOps report that we went over earlier in our presentation can help paint the picture of what are some of the advantages of making this transformation and this transition in our organization. What benefits will it have us? And a lot of those benefits can be found in that report. And I find that many times, data and research speaks volumes above any type of subjective or personal opinion. So I would suggest that you lean on that, as well as also look at Red Hat or Docker Inc. And their managed Kubernetes solutions, and they have people on staff as well that can help you make that transition and to help and help build a path for you to travel down.
Okay, all right, great. Next question, which I think is probably going to be our last one, but we'll see. Is Instana scalable to a large enterprise?
Yes, so we have customers in the more than thousands of agents at this juncture. And we also have the ability to run both as SaaS and on-prem. So the answer is yes. Now it depends on the size. If you have a number, get in touch with one of our sales reps, or we'll get a follow-up on this call and be happy to get into the weeds on that for you.
Okay, all right. So let's do one quick bonus question, then we'll wrap it up. How long does it take Instana to understand what is normal and therefore be able to detect an anomaly?
That's a really good question. How long does it take?
Hugh, I think what this question might be trying to get at is how long does it take Instana to do any type of training on the data that is coming in?
Mm-hmm. Yeah.
My understanding is that within a matter of just a few minutes, we'll have a good understanding of what normal is. But that being said, we are looking at and investigating longer tails so that we can look at issues that may happen over days, such as memory leaks and other things like that. So it's definitely something that we're looking at. But to answer that question directly, it's within minutes that we have an understanding of what is normal.
Okay, great. Well, we are at about 2 minutes to the top of the hour, so unfortunately we do have to close out the question and answer period. If we didn't get to your question, please know that the folks at Instana have a copy of all the questions, and so somebody from the organization will be happy to follow up with you following the webinar and answer the question that you have. Also want to remind the audience that today's event has been recorded. So if you missed any or all of it, or if you just want to listen to it again, you will be receiving an email after the event that contains a link which will take you right to the webinar on demand. The webinar is also going to be living on the devops.com website. So you just go to devops.com, go to the webinars tab, click on the on demand section, and the webinar should be right there waiting for you. And while you're there, go ahead and take a look at the other webinars that we have on the site, both upcoming and on demand. Hopefully there'll be one or two that pique your interest. Hugh and Kevin, thank you both so much for giving such a great presentation today. I know the audience got a lot out of it, judging from the amount of questions we had, so thank you again. And thank you to the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.